Acids and alkalis can be very dangerous chemicals. The safety symbols on these labels are a warning. The chemical inside can burn your skin. To transport acids and alkalis around, you have to take as many precautions as you can. But even when chemicals are secure in the correct containers, there's still a chance for the unexpected to happen. If there's a serious accident where dangerous chemicals are spilt, it's up to the fire brigade to clean up.
This exercise, what we're trying to achieve. Okay, then let's get ready and start up.
To do this safely, they have to know the properties of the chemicals they're dealing with. So, what are the most common acids?
Battery acid, lemon juice, vinegar, hydrochloric acid,
Sulfuric acid, acetic acid, nitric acid.
citric acid in oranges and things like that.
Acid was given its name in the 16th century by Sir Francis Bacon. It comes from the Latin word acer, which means sharp. Some acids have a sharp taste, and you get a sharp burning sensation if acid touches your skin. There are other similar words in English. For example, an acute angle is a sharp angle, which can give you an acute pain. What else do we know about acids?
It can be very dangerous.
You shouldn't touch them at all. Corrode metals. I'm not very good at science. Strip paint. Poison people. Fumes can kill you if they give off fumes. I think that's very good for a woman of my age.
It's opposite to alkali.
Alkali comes from the Arabic word kila, which means the ashes. This was because the ashes of some kinds of wood used to be dissolved in water to make cleaning fluids. You still find alkaline cleaning fluids today. So, what else do we know about alkalis?
The opposite of an acid. They can burn your skin.
All I know is that they neutralise the acids.
Sodium hydroxide is an alkali.
Sodium hydroxide is commonly known as caustic soda. It's used for heavy-duty cleaning jobs, like a block sink. Caustic soda is part of a family of chemicals called bases. If they dissolve in water, bases make alkaline solutions, so an alkali is a soluble base. Strong alkalis are just as powerful and just as dangerous as strong acids. A strong acid can be powerful enough to dissolve metal. Here, hydrochloric acid is reacting very violently with zinc. And it isn't a very good idea to keep a strong alkali like sodium hydroxide in an aluminium cup. In the strong acid, the zinc has completely dissolved, and the strong alkali solution has eaten right through the aluminium. Strong acids and alkalis have to be handled with extreme care. The chemicals in red cabbage can be used to indicate the difference between acids and alkalis. Lemon juice is a weak acid. And you can make an alkaline solution with bicarbonate of soda. The cabbage is boiled for just a few minutes. In water, the cabbage extract is purple. But it goes red when you add it to acid. The alkali makes it go blue. Cabbage extract is an indicator for acids and alkalis. But if you need to know the strength of acids or alkalis, you need universal indicator, which uses the pH scale. A solution with a pH of 1 is a strong acid. A solution with a pH of 14 is strongly alkaline. If the pH is exactly 7, it's neutral.
I'll have you.
Hi, sorry to bother you. Can I borrow your shampoo, please?
Where will shampoo be on the pH scale? Will it be strongly acidic or strongly alkaline, or somewhere in between? First, the shampoo needs to be made into a solution by adding distilled water, which is neutral, so it won't affect the pH of the shampoo. This is a special kind of indicator paper, where you have to match up 4 coloured squares to read off the pH value.
Number 6.
This shampoo has a pH of 6, so it's very slightly acidic. Not enough to be dangerous, though. What about battery acid? Any guesses about the pH this time?
Can I test the pH of your battery acid, please?
Yes, certainly.
Again, the colour of the paper is matched to a colour on the scale. With a pH of 1, battery acid is very strong and has to be handled with care.
Excuse me, can we something like that?
What about a cleaning material, like the powder used in a dishwasher? Do you think it's necessary to wear gloves? The powder needs to be made into a solution before it can be tested with indicator paper. It's a strong alkali, so best not to get it on your hands. No wonder it gets all those dishes clean. Surely human blood isn't an acid or an alkali. This time, the pH is measured electronically. Blood is neutral. The pH is right in the middle of the scale at 7. Vinegar is quite a weak acid. An electronic measurement gives a pH of about 3. The probe is very sensitive, so any traces of vinegar must be washed off before it's used again. The tank of water is neutral, so it has a pH of 7. But what happens if he adds only a few drops of concentrated hydrochloric acid? Hydrochloric acid is very strong, so it makes the pH of the water drop all the way from 7 to just below 3. The water is now as acidic as vinegar. If a road accident involves a vehicle carrying acids or alkalis, the fire brigade needs to know how to deal with the chemicals safely. Firefighters prepare for this in training sessions which are made to look as realistic as possible. First, they need to assess the risk to themselves and others.
OK, mate, are you all right? Yes. Have you got any contaminants on you at all?
No, not at all.
Are you sure?
Positive.
OK, then you approach me now. Is this the product which is actually leaking down there?
That's the caustic, yeah.
Right then. And you're feeling all right in yourself?
Yes, I am, yeah.
If you can go with this firefighter, then we'll sort you out and we'll sort your problem out over there.
After finding out that the chemical involved is caustic soda, they call on specialist advice to work out how best to deal with it.
OK. XF, Training School 1 receiving over. Informative message. Road traffic accident. 2 cars. 1 lorry containing drums of chemicals involved. 1 drum containing caustic soda leaking.
Remember, caustic soda is another name for sodium hydroxide. It's a strong alkali, so before going near the spill, the firefighters need to wear breathing apparatus and a chemical-resistant suit.
Once you're zipped up, gents, if you can go in, take a look at the container. If you can make it safe without injuring yourselves or being contaminated, make the container safe and bring the information back that you think's relevant. OK?
Because this is a training exercise, the chemicals are dyed green.
Stop there. Card on the floor. Is the incident rate safe for the time being? Right, hang on there for further information.
So we've only 1 leaking drum.
That's right.
And that's the caustic.
That's right.
Right, well, we need to obviously mop up the leaking on the floor by throwing sand on it.
Right.
We can dig that up and put that in a drum. The small package of caustic we'll put into an oversized drum and we can take that away.
Yeah.
Once most of the alkali has been absorbed using sand, the rest can be made safe by diluting it with plenty of water. But contaminated water can get into drains and eventually into rivers, so dilution isn't always the answer. And don't forget to wash thoroughly after handling any chemical.
I wish
large areas of Western Europe are covered by forest. But in recent years, many forests have been badly damaged by acid rain. Even though the rain is only very weakly acidic, it causes the trees to wither and die. Environmental groups claim that acid rain is caused by burning fuel in power stations. The energy released by burning coal can be converted into electrical energy, but at a price. One of the impurities in coal is a chemical called sulfur. When coal is burned, it gives off the gas sulfur dioxide. This reacts with water vapour in the air to form acid rain. The people who run this power station have taken steps to prevent acid rain. They use limestone, and lots of it. It arrives from a quarry which is 50 miles away. Limestone is one of the most common rocks in the British Isles. Its chemical name is calcium carbonate. When limestone is added to water, some of it dissolves. It forms a muddy liquid called a slurry, which is very alkaline. But before the slurry is made up, the limestone needs to be ground up to a fine powder in this huge mill. When coal is burned, the sulfur dioxide would normally go up the chimney and into the atmosphere. But here, it's sent into a giant reactor along these huge pipes, which are even wider than the Channel Tunnel. Inside this huge vessel, there are many reactions going on, which can be simplified as sulfur dioxide gas, which is acidic, reacts with the limestone slurry, which is alkaline, to form a chemical called gypsum, which is neutral. Another name for gypsum is calcium sulfate. Gypsum comes out of the reaction vessel in a milky liquid, which is neutral. The pH is 7. Once the gypsum has been dried, it can be made into building materials, like plaster, and used for covering walls. This power station is the first in Britain to tackle the problem of acid rain. By understanding that acids and alkalis are opposites and that they can be used to neutralise each other, we can attempt to deal with an important environmental problem. But the extra equipment used to remove the sulfur dioxide costs over £700 million. Is it a price worth paying?